Hello, welcome. Taxonomy Online Mathematics. In this episode, we want to have a little discussion on the topic implicit differentiation as the continuation on calculus 2 tutorial. Here we are saying that if y equals to the function of x, then the variable y is given explicitly in terms of x, meaning the position of y will be defined directly as the subject of that equation. So for example, we can say this: y is equals to x, that is 6x cubed minus 5x squared minus 1. So this at the right contain only x. Y is in terms of the function of x directly. That is, y is explicitly defined in terms of what? X. Alright. But some curves are defined by explicit functions. That is a function which cannot be expressed in the form y equals to the function of x. You remember the coordinate geometry 2, where we have equation of a circle that contain the x squared plus y squared plus 2g x plus 2fy. You can see that both x and y are alternating in that equation. So we can have an example here as x squared plus xy squared. In this case, you can't make y the subject in these places because it have y squared attached to x, y cubed equals to 10. So here, both x and y are involved in that equation. Then we can have what they call implicit differentiation. So because the y is in terms of the function of what? X and y. So hence, it cannot be expressed in the form y equals what? The function of what? X. So an implicit function involving both x and y can be differentiated with respect to x as it stands using the chain rule. Remember the chain rule where we can have our dy dx equals to dy if du, then du dx. You can see we are going to differentiate all of them with respect to x. So when we make the u, this is y, this is u, you can see that the du will cancel, remaining dy dx. In that case, we are differentiating every term, even though we introduce what? U as a function. Still we differentiate that u with respect to x. Same will be applied to implicit differentiation. Alright, what are the steps we are going to follow? 1. Differentiate term by term. Remember how to differentiate the sum or difference on both sides with respect to x. Both sides of the equation or the equal sign. Differentiate both sides with respect to x. Bring all the terms with the dy dx to the left and bring all other terms to the right. Then make dy dx the subject of the equation. So these are the steps we are going to follow. But we need to take note of some critical points also. Okay, let's have this. If we are to differentiate, don't forget d dx of a function. It means we are differentiating the function in the bracket. If you differentiate this, this is going to be 2y then dy dx. Remember how we differentiate. The power comes forward to multiply, then we subtract 1 from the power. So this is actually, let me just put it together since we don't have enough space. So this is going to be dy dx. If we differentiate y squared, it becomes 2y dy dx. Why? We are adding dy dx from the chain rule because we are differentiating with respect to x. So the dy dx as the change will be added to your function. Then here we are also going to bring the 3 out to become 3y 3 minus 1 square then dy dx. So in general, if you are differentiating any y term with respect to x, you are bringing the power forward, you subtract 1 from the power and introduce the dy dx attached to your differentiation. I guess this is the rule we are going to use. We already know this function. Bring the power forward, subtract 1. The only new term we are adding is the dy dx attached to our differentiation. I guess that is okay. Alright, so a question like this can be given. Find dy dx from the following. We have x squared plus y squared equal to 6. So if I have this, remember the 3 steps we outlined. 1. Differentiate what? Each term on both sides of the equation. So I'll be having, okay, let me write the equation first. So this means that dx of x squared plus dx of y squared equals to dx of 6. We are differentiating each of the term on both sides of the equation. Then if we differentiate this, remember your 2 come forward, we subtract 1 from the power, plus 2 come forward, we subtract 1, we get y, we introduce dy dx. Remember this? It's even here. Then this equals to, if you differentiate a constant, you get 0. I guess you can remember that from the previous episode. So that's the first step. Differentiate each term on both sides of the equal sign. Alright. Number 2 is to bring all the terms that contain dy dx on the left. Already I have it here. So all other terms go to the right. Meaning your 2y dy dx will be equals to, taking these 2, which is positive, become negative 2x. So we have 2y dy dx. The dy dx is not alone here. The third step says we should make dy dx the subject. And in making dy dx the subject, we divide by the coefficient. So we divide both sides by that coefficient. Meaning your dy dx will be equals to minus 2 on the right divided by 2y. And if we can check, there is a common factor of 2. So that will give us minus x divided by y. So this function being differentiated will give you negative x over y, following the implicit rule differentiation. I guess that is clear. Good. Let's take the second one. Alright, for this, as number B, we have our x squared, 6y, y squared equals to 9. The same procedure, dx of the x squared, dx of the 6y, dx of our y squared equals to the dx of what? 9. So here, if you differentiate, your 2 come forward to give you 2x. We subtract 1, the power is 1, plus, this is a constant, so it's a coefficient. Now 1 here come forward, multiply 6 to give you 6. Subtract 1 from that 1, give you 0. So y exponent 0 is 1. So we add our dy dx minus, this is 2, coming forward to give you 2, subtract 1, y exponent 1, dy dx equals to 0. Because we differentiate a constant, you get 0. So now the second step, bring all the dy dx terms to the left, which they are already here. So we send this one away, meaning 6 dy dx minus 2y dy dx equals to minus 2x. Now, we need to factorize here because the dy dx is 2. So we factorize to make it 1. That means if I put dy dx outside the bracket, dividing here, I'll be left with only 6 minus 2y. Remember, if you expand, you go back to the top. And that will still be equals to minus 2x. Now you can see that the dy dx is still not alone. So we transport this 6 minus 2y to divide both sides so that we can cancel it. So from here, you'll be having your dy dx equals to minus 2 on top, 6 minus what? 2x. This is 6 minus 2x is dividing both sides. But I can see that 6 and 2 have a common factor. That common factor is also common to the numerator. So I can rewrite this as dy dx equals minus 2x divided by 2, 3 minus x. 2 times 3, 6. 2 times 1, 2. So the 2 can cancel to give us our dy dx equals to minus x in the numerator divided by 3 minus x. So this is the differentiation, the dy dx of the function x squared plus 6y minus y squared equals to 9. I'm sure the concept of implicit differentiation has been grasped by you. Thanks for watching. Don't forget to share this video with somebody who may also benefit from it. Like, comment, and subscribe. Bye-bye.